we reject the null hypothesis in a one-way ANOVA, all we know is that our population means are not all the same, but we don't know which means differ from which. In order to find that out, we need to complete follow-up tests. In this video, we'll be talking about follow-up tests, specifically planned contrasts and post hoc comparisons. And specifically, we'll be focusing on when you need a planned contrast versus a post hoc comparison. We'll talk about some different planned contrasts and post hoc comparisons just in a little bit of detail, but our main focus is going to be on when you should use each test. So for our ANOVA, if we reject our null hypothesis, what this means is that our population means are not all the same. But it doesn't tell us which mean is different from which. It doesn't tell us whether that's bigger or smaller or which one it's compared to. We still have to figure that out. And this is only in the case that we have rejected our null hypothesis. If we have failed to reject our null hypothesis, that means that our population means are the same and there's nothing more to do. But it's only in the case that we reject that null hypothesis that we have to follow up on this. So we have to do still one more analysis, and specifically we want to compare pairs of groups. And there's going to be two ways that we can do this. Specifically, we can use a planned contrast or an a priori test, and this is used when we plan in advance which means that we'll compare. This is based on specific predictions. So for example, in the example that we were just going through in the last video, this could be that I predict that the medicine and therapy group is going to get better results than the medicine group or the placebo group. And so in that case, I would predict that group 3 is going to be better than group 2 and better than group 1. And I'm going to look at those in pairs, 3 and 2 and 3 and 1. For a post hoc comparison, these are used when we don't have a specific prediction about which means will differ. It's just that we've predicted that something will be different, but we haven't made a prediction about what. And so post hoc comparisons are more exploratory, and they actually test all of the possible comparisons between all of our groups. And again, this is in contrast to these planned contrasts, because in these cases, we're only going to test the specific pairs that we have made predictions about. For the post hoc comparisons, we're testing everything, all possible comparisons. And so we'll go into just a little more detail here, but overall, we'll be looking at this in SPSS, but we really won't be calculating these by hand. So this is just a little more additional background. But the main thing to take away from this video is going to be in what situations that you should run a follow-up test and when that follow-up test should be a planned contrast versus a post hoc comparison. So with that in mind, a little more detail about our planned contrast. So for this, how this would work is that, if we wanted to calculate this by hand, we would figure the within groups population estimate the same way that we did for our ANOVA. We're going to figure the between groups population estimate for our ANOVA, except only using the two means that we're interested in. And again, this is after we've done the ANOVA, after we have rejected the null hypothesis. And then using this adjusted between groups population estimate, we're going to figure our F value in the usual way. And then we're going to compare this F value to a cutoff score based on the normal DF within and the DF between based only on the two groups. And so this is going to change our cutoff score as well. And so we're going to compare that, and that comparison happens the same way. So if our F value, our sample value, is more extreme than our cutoff score, then that's going to mean that that pair, that analysis of that pair is statistically significant. Continuing thinking about planned contrasts, we have this particular issue that comes up that when we carry out multiple planned contrasts, it actually becomes more likely that we're going to reject the null hypothesis when the null hypothesis is actually true. And so specifically, when we talk about this, this is the case that we are going to make this decision, but there's some kind of decision error happening, as we talked about earlier in an earlier video. And so when we carry out these multiple planned contrasts, essentially, we're actually going to be taking on more risk of making this kind of decision error than we intend to. And so, for instance, when we're using a 0.05 significance level, we'll actually have much greater than 5% chance of rejecting the null hypothesis when we shouldn't. If we do multiple of these contrasts, it's going to wind up inflating this likelihood of making this kind of decision error. And so often we don't use the Bonferroni procedure when we're only making 2 or 3 planned contrasts, but if we're making lots and lots of planned contrasts, the Bonferroni procedure is actually going to adjust the significance level, making it more extreme, making it harder to reach. And that's going to really bring that likelihood of making that kind of decision error that we're worried about with making these multiple planned contrasts, inflating that significance level. This is going to really correct that problem. And so in order to complete the Bonferroni procedure, we're going to pick the significance level that we want, and we're going to divide by the number of planned contrasts that we intend to make. And so for instance, if we want a significance level of 0.05, our conventional significance level, and we know that we're going to make 3 planned contrasts, which again, we might not necessarily use the Bonferroni procedure with only 3 contrasts, but just for an example here, we're going to divide 0.05 by 3. We'd get 0.017, which we could round to 0.1 because that's the closest thing that's going to be on our F table. And that would change our significance level, that would change our cutoff score drastically, actually. And so in this case, we're using this 0.01 significance level, and we still have our degrees of freedom of 2 and 12. So I have my 12 over here. Now I'm using the 0.01 significance level instead of 0.05. Moving over to my degrees of freedom in the numerator, and that gives me 6.93. Again, this is increased from my original cutoff score of 3.89. That was my cutoff score for the ANOVA. And so if I put my cutoff score now by where that 6.93 is, this is now much, much more extreme. It's going to be much, much harder to get a sample score that is beyond that cutoff, that is more extreme than that cutoff score. And so it's going to make it harder to reach this level of significance. And this again is to correct for that artificially inflated likelihood of us making that decision error. For a post hoc comparison, the example that we're going to look at here is the Chaffee test. And specifically, the Bonferroni procedure would be too extreme here. We want to kind of balance the desire to be conservative and not make one type of decision error with the possibility that we can make the other type of decision error that we've talked about, those type 1 versus type 2 errors. So we need to balance things here, and we don't want to make it too difficult either. And so the Bonferroni procedure would be too extreme, that would make it unlikely that we would ever reject our null hypothesis, even when we should. And so the Chaffee test, how this works is that we would figure our F value for the paired comparison in the usual way, the way we would if we were doing a planned contrast. And then we're going to divide our F value by the overall study's DF between. And we're going to compare this much smaller F to the overall study's F cutoff. And so for instance, we have we're going to figure our F value for the paired comparison the way that we would have in the instructions that we talked about just earlier about planned contrasts. We're going to divide F by the overall study's DF between. So we've figured out our F value. We're going to divide it by the study's DF between, and that's going to give us 2.11. And so that now brings our F value makes it much, much smaller, really brings it down. And so now we're going to compare this 2.11 to our original cutoff score. And we're going to see that now we would fail to reject this hypothesis. This would be not significant because that sample score is not more extreme than our cutoff score. And that is the Chaffee test. And there are other tests that we could do as well. There is the Tukey test. There's all different kinds of other tests that we could do also, but we won't be talking about these. We're going to leave it here. And again, remember the main takeaway here is when do you need to do follow-up test? And in what situation do you use a planned comparison versus a post hoc test?